explain X-ray photoelectron spectroscopy. This is a chemical characterization technique of material surface, and this is based on the photoelectric effect, which says that when energetic photons strikes on a surface, it emits energetic electrons with kinetic energy, and that kinetic energy is dependent on the photon energy and photon energy this and the binding energy of the energy level from where the electron has been ejected, and the work function of the sample. So if we can control h nu, or we can keep constant h nu, then if we put we can get different kinetic energy for different binding energy. Thus, if we can measure the kinetic energy of an electron, then we can have the information of the binding energy of the material. So now if we account for different kinetic energy, the electron number, then we will get this type of spectra, where these peaks corresponds to different orbital or energy levels. How? Let me explain you. Every material has atoms, and those atoms have energy levels or orbitals which corresponds to different energy levels, and these energy levels or orbitals possess some number of electrons, and in this way these are the energy. So if some electron are ejected from this, they will have different binding energy. From this, they will have different binding energy, and and for that we will get different kinetic energy. So if we can go on scanning the kinetic energy, we will get peak here and then zero, then we'll be here zero, and that's how we get this spectra. But the problem is that here we have when measuring the kinetic energy, we have phi sample here, and for every unknown sample, this is unknown, so it is very difficult for us to estimate. So actually this is not the case. The phi, it is not the sample work function, and that will be clear if we go to that next part. This is the energy diagram of a sample and a detector. Electrons, when electrons are rejected by photons, X-ray photons, they come to the Fermi energy, and then they are free, becomes free after crossing this work function, and so they are get the kinetic energy that is equals to h nu minus binding energy minus phi of sample. But when this is measured here, we have a error of this amount, and that is the difference in phi in spectrometer minus the phi in sample. So this error must be reduced from the measured value, and finally we get the kinetic energy is equal to h nu minus binding energy minus phi of sample minus the difference spectro minus sample. These samples work function cancels, and we finally get binding energy minus phi of spectrometer, and this spectrometer work function is constant for the instrument, so we can get the binding energy curve, and then we can get the X-ray photoelectron spectrum.